Okay, so I'm recording this. All right, so it's going to be on the second floor. The classroom, though, when you look at your schedule, it says first floor, room 118, I think. But it's a huge room. There's only about 25 of you, and on the second floor there are computers. So if you get there early, you can start working on MyLab assignments. So that's why I put on the second floor, because of those computers. All right, so don't forget next week. I'll have the room number will be on the first floor, the regular room. It'll tell you where to go on the second floor. So don't forget, it'll be on the second floor. When you get off the elevators, just take a left and it's right there. So it's right in front of the vending machines. All right, and then the other thing I want to remind you of is this. So in the table right here, so there are 3 MyLab assignments that are currently assigned, and the JIT are called just in time, so those are prerequisites to, in this case, section 1.2. So I said you can wait until today to start your 2-week free trial if you don't have the money to get MyLab, but make sure you start today. So remember, to get to it, I sent you all last week. See right here? Let me go ahead and turn this into student view. So I'm in student view, but right here in the weekly agenda, you see where it says registering for MyLab? So when you go there, click on the down arrow, it will open it up, and these are the instructions. And I sent y'all that, right? Okay. And so there's a video that they have that you can watch as well, but notice it says sign into your Canvas course, so this Canvas course, and select MyLab and Mastering or Pearson Access. In this case, it will be right here, Pearson Access. Let me get back to this. All right. And so you just open Pearson Access, you agree to privacy policies, you enter your Pearson username and password. If you don't have one, you would create an account and then select Link Accounts. If you see a confirmation page, select Continue, and then choose an access option. So if you purchase a code, let's say from the bookstore, then you would do that. You could pay by credit card, or you can do the free 14 free day temporary access. But it's only good for 14 days. So 14 business days. Business days include, 14 calendar days, including Saturday and Sunday. But after that day, you're going to have to pay the $75 or $79, whatever it is, to continue working. All right, and then right here they have something about the upgrade. But this is where you go. You just go to Pearson Access to get the assignments, to start on these assignments. It's very straightforward when you get to it. Very easy to get to those assignments. Any questions on those? Some of you have started. Okay. And then the other thing I want to remind you of is that the key to the worksheet you just turned in is right here. So the key to worksheet 6, remember that was due yesterday. So your grades are posted, and there's a key. So there's a PDF, and then there's a video. So if you download the PDF, and then you open it up, there's the key. All right, so there's number 1, and then number 2, the steps I was expecting you to do. So when doing something like number 2, I really wanted you to use the LCD and to multiply both sides by the LCD to clear the fractions. There were some of you that did not. Some of you used fractions throughout. When you do that, it makes things a little bit more complicated for you. But clearing the fractions first makes things so much easier for you. But there's a key, so make sure you look at the key. Now remember, you should have received, whenever I post a grade, you should receive something from Canvas, I think. But all you do is go to grades right here. So you click on grades. And when you click on grades, I'm in the student view, so your grades should show up. So this is just a test student. So you could arrange by due date or module or name. I usually prefer assignment group. And by assignment group, what that does, and then click apply. And what that does is it puts all the MyLab assignments together. See where it says MyLab assignments? So it puts those first, then it puts the worksheets second, and then the attendance third, and then once you get a test, the test will be somewhere in there as well. But it puts them in groups. So notice you have all your MyLab assignments listed, you have your worksheets listed, and so on. And then here was the due date, and then the score. So all of these were 10s except for the participation, which are 1s. But this, remember, this is just a fake student. So 10 out of 10, 7.5 out of 10, and so on. Now, right here, see right here? This is important. So if I click on this right here, if I click on that, that's a comment. Let's see what it says. I'm trying to see how to get to that comment. It's supposed to be easier than that. Oh, I said not complete. So there's a comment there. So if you see something like that, then click on it to get to whatever comment is. And then over here, click on that one. Okay, now this is important. So when you got your worksheet, if you did not get a 10, I made the corrections. I even put with it the key. So here's the feedback. So you need to click on this. So when you click on this, so when you go to yours, if you did not get a 10, you should have one of these. So when you click on it, and then notice the first page will be your score and all the comments I made. And the second part, when you scroll down, will be the key. All right, so always go to your two grades to see anything I've given back to you. And then remember, for participation, I expected y'all to put something that was math related. So most of you will, almost all of you get 1s out of 1s, but sometimes you're not specific. Some of you will say something like, I worked on the worksheet. Well, be a little bit more specific. What worksheet did you work on? All right. And then scroll all the way to the bottom. Down here will be your current percentage. All right, so any questions on grades? So just make sure you look at yours to see what you have, especially the worksheet, because the worksheet 6 was something you got back. And if you didn't get a 10, then when you click on it, like when you click on this is what I sent back to you. All right. Okay. And so that's basically it for this part. Any questions at this point? Okay. All right. Now, so if I go to back to the home page, and so remember for Agenda 2 right here, these are the non-graded worksheets. Non-graded worksheets, so the key's already posted for those. Remember, non-graded worksheets are not to be turned in. I don't expect any work to be turned in. Those are just extra practice for you because you're going to need these non-graded worksheets on the test as well. And then here are the keys to the graded worksheets, which are not posted yet because those are due Monday night. And here's the summary that I sent to y'all last Sunday, I think, about this week. And so when you click on the agenda right here, this is what I wanted you to do on Monday, what I wanted you to do on Tuesday, and so on. And so notice that each of those sections you have lessons. So if I click on this one right here, here's a lesson on literal equations. And so that's one something you're going to need to be able to do for one of your MyLab assignments. Let's go back, and the same thing. And then there's a non-graded worksheet that goes with that one. So when you click on it, notice that if it was graded, remember if it's graded, you should see something up here that says start assignment. Remember that? It'll say start assignment. This one doesn't. So if it doesn't, what does that mean? It means it's not graded. But here's a worksheet. So you open it up. And there's some problems on literal equations. Now remember, it's not graded, so the key's already posted. So remember where the key is. So the key is, you go to the home page, and that was equations worksheet 5. You scroll down, and that's it right here. So you click on it, there's the key. All right, so any questions at this point? Okay, now one other thing I just want to say, so usually what, I'm sorry? Hello? Okay, so what I also want to say is that sometimes what students do, which is not a very good idea, is they'll go to assignments. See right here, assignments? Let me kind of see if I can point to it a little bit better. So they'll go here to assignments, and when they click on it, you'll see this right here. So you'll have upcoming assignments. So these are all the assignments that are coming up. Notice the due dates are listed. See all those? And then the point values. Want to say this about, see right here, there's already some point values, even though it says upcoming assignments. So remember, in MyLab, it updates nightly. So if you started working on it and you at the end of the day had 2 out of 10, it will show 2 out of 10. But remember, you can still continue working on it until the due date, and the due date is February 1st. Okay, so remember, MyLab updates nightly. So that's why you see some scores when you go to assignments. When you go to assignments, you'll see some scores here. But you have until February 1st, until the due date, in this case, February 1st, to improve your score. Okay? All right, so these are your upcoming assignments. Then undated assignments. So notice something about that. So these are assignments that are undated. So students get confused here. They think that these, and because they go straight to the assignments, they get confused. Undated assignments are assignments that don't have a due date. So these are non-graded worksheets. That's what these are. These are your non-graded worksheets. You see equations worksheet 5? That's a non-graded worksheet. It's not to be graded. I don't have a due date because you're not to be turning it in, but you are to be working on those because those are on your test and final exam. All right, and then your past assignments. So these are all the assignments that are past due, so they're done. So notice one of those is yesterday's participation. The information you had to turn in yesterday. So all these were from yesterday. Nope, I'm sorry, not all. Today's Wednesday. Okay, so the participation here is from yesterday. You had a lot of stuff that was due Monday. Okay, so any questions on this part? All right. But what I was going to say is some students get themselves into trouble because they go here. That's the first thing they do. They go here to assignments, and then they see equations worksheet 1. They click on that, and then you see this little start assignment. That's where you start your assignment, right? So you're going to scan or take a picture, and then you're going to upload it. You're going to start your assignment here. So you click on start assignment. The problem when you take a picture is you're going to have to take a picture of each page. If you have 5 pages, you're going to have to take a picture of all 5 pages, and then you have to upload it 5 times, or all 5 pages. So you have 5 of these things. That's a long time. So there are some scanners. So if you go to your app store, there's some scanners, some free scanners in which you can um, upload multiple pages at once, and you just have to do one document. But I think some of you may be using Canvas Student App. So I think Canvas Student App, you can scan multiple pages. So I mentioned that last week you could possibly look at the Canvas Student App. And then you just click Submit Assignments, and that's it, right? So all of you had practice in this because you had a worksheet due Monday. All right. But I was going to say is that, let me go ahead and leave this. Some students get themselves into trouble is because they go to assignments and they go to the worksheet here. They download it right here, and then they want to start working on it. Well, you got to be careful. So you may have forgotten a lot of stuff. In terms, see right here it says show all work. If you don't show all work, you're not going to get full credit. So it is a very good idea that you go back to the addenda. So that was in week 2. So in week 2, it's opening up in week 2. Come on. So let's go to the graded worksheet. So let's see, right here. So equations worksheet 1. That was one I just opened up. The um, the lessons that go with it are right here. So this worksheet, part of it deals with factoring, and then there's a problem from the last week, but there's a problem on here with factoring, and so the lessons on factoring is this right here. All right, so always make sure you, if you go to assignments and you go straight to the worksheet, that you actually go back to the agenda right here to view those lessons, because your work needs to be like what I have in those lessons. All right, any questions on that? Okay, all right, so what I want to do now is this. Okay, so one, just kind of review something something from last week that you had. So from last week you had to solve this equation. So we have x plus 3 divided by 4 minus 6 equals 3x minus 1 divided by 3. All right, so you had something like that. Now the way I wanted you to do this is to use the least common denominator. So you see you have fractions here. And so you want to multiply both sides by the least common denominator. And so if you look at all these fractions right here, what's the least common denominator of those fractions? Anyone? 12. So the smallest number that 4 and down here, that's a 1, and 3 go into is 12. And then let me go ahead and mute you. So once y'all say something, go ahead and mute, because then there's usually a static. So I'm gonna go ahead and mute. Okay. So then the next thing you're going to do is you're going to multiply both sides by 12. Notice though on this side there's like 2 fractions here. You see one fraction and you see another one. Although this right here you can write as 6 over 1. So what you're going to do, let me go ahead and rewrite this. What you should, and this is very similar to last week's worksheet. I think it was number 2. So you're going to multiply both sides by 12 like this. What you do to one side, you have to do to the other. And then notice I introduced parentheses, so now you can distribute. And so I get 12 times x plus 3 divided by 4 minus 6 times 12. So this will be multiplied by 12, and this will be multiplied by 12, equal, and I'm going to just go ahead and rewrite this over, 3x minus 1 divided by 3 times 12. All right, once you get to that point, the next thing was to reduce. So remember, the whole purpose of multiplying both sides by the least common denominator is to get rid of these fractions. So if you're doing this correctly, you should now be able to. 4 into 4 is 1, 4 into 12 is 3. 3 into 3 is 1, 3 into 12 is 4. And now what we have is this. We have 3 times x plus 3. So notice x plus 3 is in parentheses, minus 6 times 12. And you have access to calculator, so use your calculator if you have to. 6 times 12, right? 72. Equal, and then 4 times 3x minus 1. So notice I no longer have any fractions. So I have this linear equation. So I'm going to use the distributive property again. I'm going to do it twice. Use the distributive property twice to get rid of the parentheses. 3 times x is 3x. 3 times 3 is 9, so 3x plus 9 minus 72 equal, and then 4 times 3x is 12x, and then 4 times negative 1 is a negative 4. At that point, you're going to combine like terms. A 9 and a negative 72. Use your calculator. 9 minus 72 is negative 63. So I get 3x minus 63 equal 12x minus 4. Now remember, at that point, this is where you bring all the variables to one side, constants to the other. So I'm going to subtract 3x from both sides. So subtract 3x, subtract 3x. So what you do to one side, you do to the other. 3x minus 3x, that is 0. And 0 to negative 63 is a negative 63 equal 12x, and a negative 3x is 9x minus 4. And a couple more steps and you're done. Okay, so now right now I'm subtracting 4. The opposite is to add 4. So we have to add 4 to both sides. What you do to one side, you do to the other. A negative 63 plus 4 is a negative 59 equal 9x. This is 0. Negative 4 and 4 is 0. And then we're going to divide both sides by 9 to get x by itself. Because remember, right now you're multiplying by 9. The opposite is to divide by 9. And then you cannot reduce this, so you're done. And don't leave it. Some of you are putting things as a decimal. The problem with putting as a decimal is many times it doesn't terminate. So when you say that's the answer, it really isn't. It's an approximation. So leave it as a fraction. And so you say x equal negative 59 divided by 9. Now, if you want to write this, this is an improper fraction. That's a 9 right here. So if you want to change that to an improper fraction, to a mixed number, you can. 9 into 59. So let's see, 9 into 59, and what you can do is just say this, 59 divided by 9. So 6, so you're going to say 6. And then 9 times 6 is 54 with remainder 5. So you can say x equal negative 6 and 5/9. So either one of those is fine. All right, so that's something you had last week. And I wanted to do this because some of you did not even multiply both sides by the least common denominator. You multiply both sides by 3, which I did not know why. But the whole purpose of multiplying both sides by number is to clear the fractions. And so use the LCD. All right, so that's something you had to do last week. And one other thing, I think it's either last week or maybe this week. So the other thing is the idea of literal equations. So let's talk about literal equations. All right, it may be something you learned Monday of this week. So a literal equation is basically an equation with one or more variables. And so you'll see something like this. Let's say number 1. You have k equals a plus b, c like this. And so notice you have a lot of variables, right? A lot of letters. And they're going to ask you to solve for a variable. Let's say b in this case. And so what you have to do is use the same things you use here, use those properties to help you get b by itself. And so notice the only term that has B in it is this one right here. So since that's the only term, you need to get rid of this A. And one way to get rid of that capital A is to subtract A from both sides, just like that. So what you do to one side, you do to the other. And so I have K minus A on the left side. See, the left side is K minus A equal A minus A0, and you're left with B times C. All right, now this is very similar right here to what we had here. So if I have 9x and I'm trying to get x by itself, to get x by itself, since I'm multiplying by 9, you divide by 9, right? Well, the same thing here. If I'm trying to get b by itself, notice I'm multiplying b by c. Well, since I'm multiplying by c, then I have to divide by c. And so the c's divide out, and you get b equal k minus a divided by c. And there's your answer. So you solve for b. So solving for a literal equation uses the same properties that you did when solving in the previous section linear equations. So if you look at number 2, so let's suppose we had x equal 2ba plus 2bc. And this time you want to solve for capital B. Now this time's a little bit more complicated because when I did number 1 and I want to solve for lowercase b, there's only one term that had that variable I was looking for. Here, if you notice, both of those terms on the right side have the letter I'm looking for. So here's what you have to do. You're going to have to remember some things from previous courses. So the idea of factoring. So you have to use factoring here. So notice that I have a b here and a b here. So you're going to factor out the b. So notice what I have. Notice equal sign aligns with this equal sign. So you're going to say b times, you're factoring out a b. So you're taking out a b. So if I take out a b, just kind of like this being removed, you have 2a left, plus you're taking out the b, you have 2c left. And you can always check yourself. See this right here, I'm saying is this, which it is, because if you use the distributive property, b times 2a is 2ba, plus b times 2c is 2bc, and then that's equal to x. And then now to get b by itself, just like I did this, to get this b by itself, I'm multiplying by c, so the opposite of multiplication is division. Over here, to get b by itself, I'm multiplying by 2a plus 2c, so the opposite of multiplying by 2a plus 2c, let me go ahead and rewrite this over. The opposite of multiplying by 2a plus 2c is to divide by 2a plus 2c, divide both sides. And now these divide out. So you left, when it divides out, you really left with a 1 here. Anything divided by itself is 1. B times 1 is B. And you get x divided by 2a plus 2c. And that's how you do that one. And if we look at one more with this, so let's look at number 3. So we have 1 divided by x plus 1 divided by a equals 1 divided by b. All right, in this case, I want to solve, let's go ahead and say you want to solve for lowercase b here. Okay, so the way to do that is to recognize, just like you did this, you have fractions, right? So you want to clear those fractions. So you're going to find the least common denominator. And so if you look at your denominators, you have x, a, and b. X, a, and b. So your least common denominator has to include all of those factors. So x is going to be here, a is going to be here, and b is going to be here. So your least common denominator is x times a times b. Once you find your least common denominator, just like you did this, you're going to multiply both sides by the least common denominator. So let me go ahead now and rewrite this over. It's not that difficult. So you're going to say times XAB times XAB. What you do to one side, you do to the other. Just like I did this one, I then did the distributive property. Do the same thing here. This times this, this times this. So XAB times 1 over X plus XAB times 1 over A equal, and then you're going to rewrite this over. 1 over B times XAB. Now remember, it's very similar now to what we had here. So once we got to this point, remember the next step was to reduce. The whole point of multiplying by the least common denominator is to clear the fractions. So at this point, you're going to reduce. So watch what happens. The x's divide out. See that? Here, the a's divide out. Here, the b's divide out. And then what you have left is this. You have 1 times a times b times 1, which is just ab, plus x times 1 times b times 1 is xb, equal 1 times x times a times 1 is xa. All right, now, notice I no longer have any fractions. So now let's go back to see what I'm looking for. I want to solve for b. Well, notice the terms that have b that I'm looking for are all on the left side. None, this term doesn't have b, but these two do. So I got to solve for b. So you're going to do this the same way you did this. You're going to factor out the b. So here, since b is what I'm looking for, and they're in both terms, you're going to factor out the b. So you get b times, so you're taking out a b. So just think about this b no longer existing. So you have a plus, you're taking this b out, you have x. So this right here is the same as this if you were to use the distributive property. And then that's going to equal xa. And then to get b by itself, right now multiplying by a plus x, the opposite is to divide by a plus x. And the a plus x's divide out, so you get b equals xa divided by a plus x. All right. And so that's the idea of literal equations. So remember though, let me go back and pull this over right here. So if you go to the agenda for week 2, right here, see where it says literal equations and formulas? So the non-graded worksheet is this one. So if you want more practice, you're going to go here. You're going to click on that. You're going to download the worksheet. Remember, this is non-graded because you don't see that little part right here where it says start assignment. Click on this. And then I think there are 5 problems you can work on. Yeah, so there are 5 problems you can work on. But the key is already posted. So remember, to get to the key, remember this equation is called Equations Worksheet 5. To get to the key, you're going to go back to the home page. And the key is where it says Keys to Worksheet Not Graded. So here's the key to Worksheet 5. And the video is here, and the PDF is here. So if you click on it, there's the key. Okay? All right. So probably tomorrow, I'm going to assign, let me go and see if I can, I don't know if I'll be able to show you because I'm in student view. But tomorrow I'm going to assign the MyLab assignment for 12-13. So let's see, hold on, let me just do this. I'm going to leave the student view. I'm going to go back to the home page. I'm going to just go to Access Pearson. I'm going to Access Pearson. Open Pearson. And I'm going to go to, I'm not sure what yours looks like. Yours obviously doesn't look like this. I'm going to go to MyLab Assignment Manager. And let's see. So it's going to be the one that says linear equation, literal equation. So when you actually go to it, it'll look like this. All right. So remember, all of this is from last week as well. So it says determine if -6 is a solution of the equation 6x equal 30. So remember, to determine if it's a solution, you substitute -6 into x. So 6 times -6 is what number? What's 6 times -6? -36, right? Yeah, is -36 equal to 30?
-30.
No, so then you say it's -6
-36,
solution, you
yeah.
can say no. And then I think
No.
there's a little final check right here. You click on that, and you go to the next question. But I think you can skip questions. But anyway, you can skip questions as you go through it, but you have to come back and answer all of them. Let me see if I can. All right, and then this one's easy. You want to solve for x. Hopefully all of you can do that. 2x equal 8, what's x? Yeah, so you put 4 here. I think you can use your keyboard,
4.
because I don't see a keyboard here. Maybe, let's see. Yeah, you have to use your keyboard. So you're going to do 4, and then say check. So some of the questions are fairly easy, not all of them. Let me just scroll through and see if I. All right, now here, I'm not going to do this one, but what's the first thing you're going to do from last week? What do you have to do first? Yep. Yeah, very good. Distributive property. Let's go to 20.
Distributive property.
And over here, what's the best way to do that one, like I just said? Yeah, what's the LCD?
Find the
That's the smallest
LCD.
number that 9 and 5 will go into. 45. So you can multiply both sides by 45 and go from there. Let's see. Let's go
45.
Okay, so we're going to look at something like this in a little while. Let me just go to the next one. I'm trying to get to the literal equation. All right, so here's a literal equation. So this one's easy. To solve for Q, I don't know if you can see this, but to solve for Q, it's just one step. What do? Well, I think that's a pi. So this is 5
Are you
pi Q.
multiplying
5 pi Q.
5 and Q?
So to get Q by itself, since I'm multiplying Q by 5 pi,
Oh, yeah.
what do I have to do to get Q by itself? Divide. Yeah. So you would have U divided by 5 pi, I think. I don't know how that's going to look. So that's going to be a fraction. So I got to find the fraction. So you see the fraction right here? Let me see if I can get to it. So you're going to use this fraction. See this little fraction bar right here? You're going to use that. Type it in. So you see it puts a fraction. I'm going to need U on top. I guess I can use the keyboard U. Let's just see what happens if I use the keyboard U. And then the bottom, I'm going to need 5 pi, and it says using pi as needed. So 5, and I need pi. Well, there's no pi on my keyboard, I don't think. Oh, wait. So here, right here, watch. Let me go and show you. Here's the pi right here.
Yeah, it's yeah.
See it? So just use that one. All right, so it's supposed to look like this now. And then you check your answer. And we got that one right. Okay, so any questions on this? All right. I didn't, some of those MyLab assignments have quite a few questions. So just make sure you're working on it as from now on a daily basis, and just try and get as much of these as possible. So at the end, I believe at the end I'll drop about, I forgot what the syllabus says about MyLab. I know the worksheets are 25%. I dropped the lowest 25%. I think I do the same thing with MyLab. So for every 5 MyLab, I drop, no, I think I said, I can't remember what I said. The syllabus says 20 or 25%. If it's 25% for every 4, I drop 1. If it's 20% for every 5, I drop 1. Can't remember what it says, but anyway. Okay, so any questions on that? I want to go back to, and I can't remember which one it is, but I'm going to go and do one like we saw earlier. Let's see. Okay, something like this. See where you have in the denominator a variable expression that has 2 terms, x minus 2, another x minus 2. So let's kind of look at that for a moment. And move this over. Move this over. Okay, so let's look at this for a moment. So that may help you with this. Okay, so this is kind of part of section 1.2. And if we have something like number 1, we have 6 divided by x plus 5 divided by 3 equal 1 divided by 6. So you want to solve this equation. Notice that this equation, and by the way, these are called rational equations. And the reason they're called rational equations is because if you look at the denominator, this denominator is a number, this denominator is a number, but this one contains a variable. So if you see an equation where you have a variable in the denominator, then that's called a rational equation. And you want to solve this rational equation the same way you did this. Now this right here, this in particular, you can consider this a rational equation because it has a number here. So we can call this a rational equation. But in particular, this right here is a linear equation. And the reason it's a linear equation is because you don't have any variables in the denominator. The variables are located in the numerator, and the exponents are 1s. So whenever that's the case, whenever the exponents are 1s for the variables and they're all located in the numerator, that's a linear equation. It's still a rational equation because it's a rational fraction right here. You see, it looks like a fraction, right? This is a fraction, 6 divided by 1. This is a fraction. In particular, though, this rational equation is not linear. This one's not linear. The reason it's not linear is because the variable is in the denominator. Okay, but the idea is the same. You want to find the least common denominator. All right, now, some students find this a little bit difficult, but what I would do first is I would forget about the variable for right now. If you look at the numbers, what's the smallest number that 3 and 6 go into? 6. So my least common denominator is going to have a 6 in it. But then I also see another term,
6.
another factor. What other factor do you see? X. So my least common denominator is going to be 6 times x. And that's it. There's your least common denominator. So your least common denominator, remember one way to kind of figure out if you have it correct is this. The purpose of finding the least common denominator is to get rid of those fractions. So if I multiply both sides by 6x, then this x better be here, and I see it. If I multiply 6x by this fraction, this 3 better be part of this, and it is, because 6 is 2 times 3. And then 6, you see a 6 here. So that's your least common denominator. Now what you're going to do now is you're going to multiply both sides by the least common denominator, just like you did here. So I'm going to rewrite this over. 6 divided by x plus 5 divided by 3. And you're going to multiply both sides by the least common denominator. What you do to one side, you do to the other. Now the next step, remember the next step here was to use the distributive property. Do the same thing here. So 6x times 6 over x plus, and then 6x times 5 divided by 3 equal, and then 1 divided by 6 times 6x. And just like we saw here, the next step, remember the whole purpose of multiplying by the LCD is to clear those fractions. So now you can reduce. You can reduce now. The x's divide out. The 3 into 3 is 1. 3 into 6 is 2. And the 6's divide out. And now look at what we have. 6 times 1 times 6 is 36. Plus 2 times x times 5 is 10x. Equal 1 times x is x. And so notice I have a linear equation. This is linear now without any fractions. So I went from a rational equation to a linear equation. All right, now based on what you did last week, I need to get all the x's to one side. So let's go ahead and bring the x's to the other side. What do I need to do to both sides to get this 10x to the other side? Do you remember? Subtract. Yep, subtract 10x. Because right now you're adding 10x. The opposite is to subtract 10x. Notice what I do to one side,
10x.
I do to the other. Then when I combine like terms, 10x minus 10x is 0. So I'm left with 36 plus 0 is 36 equal. And remember, there's no number here. It's understood to be a 1. So what's 1x and a negative 10x? Basically, you're asking yourself, say it again? A negative 10. Let's think about this. A coefficient is 1
Negative 10.
plus a negative 10, right? 1
Negative 10.
plus a negative 10. What's 1 plus a negative 10?
Negative 9.
Negative 9, yeah. So it's negative 9x. So 1x minus 10x is
Negative
Negative
9x.
9, sorry.
And then you get x by itself. Now this is where some of you messed up. So something like this was on the last worksheet. Some of you divided by 9. Are you supposed to divide by 9 or negative 9? Negative 9. You divide by the coefficient. So the coefficient is negative 9. So negative 9 divided by negative 9 is 1. 1 times x is x. Equal, and 36 divided by negative 9 is a negative 4. And so there's the answer there. So that's how you do that. So that's very similar to something that was on the worksheet last week, something like that. All right, let's look at this one. Let's look at, I'm going to need another page for this one. So let's look at number 2. All right, so number 2, you have x minus 6 divided by 2x plus 1 equal x plus 5 divided by x. All right, so notice I have this rational equation. It is rational because I have variables in the denominator. But I also have fractions. I see some fractions here, so I got to find the least common denominator. So if you look at 2x and x, remember when trying to find the LCD, think about what this needs to be in order for this to be in here and this to be in here. So what do you think this needs to be, this LCD needs to be if you have 2x and x? 2x. Very good. Because 2 is listed
2x.
and x is listed, right? And then this x is listed here as well. Don't list it twice, only list it once. So your least common denominator is 2x. So then you're going to multiply both sides by 2x. I want you to notice, though, on this one, I think we did one earlier. Let's see if I can find it. Well, maybe I did not. Okay. So I want you to notice, though, on this side, you have two fractions, this one and this one. So you can put that in parentheses. So x minus 6 divided by 2x plus 1 in parentheses, and you can multiply by 2x. And remember, what you do to the left, you do to the right. So x plus 5 divided by x times 2x. And then now you're going to distribute again. So you get 2x times this fraction. So 2x times x minus 6 divided by 2x plus 2x times 1 equal. And then I'm just going to go ahead and rewrite this over. So you have x plus 5 divided by x times 2x. All right, now remember, the whole purpose of multiplying both sides by the least common denominator is to clear those fractions. So at some point, you should no longer have any fractions. So if I look at this, the 2x's divide out. And over here, the x's divide out. And what you have now is this. 1 times x minus 6 is x minus 6. Plus 2x times 1 is 2x. Equal. Now over here, be careful because you have x plus 5. And then notice this is 2 times 1. So remember, multiplication is commutative. The order in which you multiply does not matter. So 2 times 1 is 2. And I'm going to write this as 2 times x plus 5. But put x plus 5 in parentheses, because all of this has to be multiplied by 2. Okay, now the next thing I can do is here. On this side, I can combine like terms. And on this side, I'm going to use the distributive property. So x plus 2x is 3x, right? And then 3x minus 6 equal, and over here I get 2x, and then 2
Yes.
times 5 is 10. All right, so I have this linear equation. I'm going to go ahead and bring the variables to the left-hand side. So I need to get rid of this 2x. So adding 2x is not going to help me because 2x plus 2x is 4x. But subtracting 2x will, because 2x minus 2x is 0. But what I do to the left or to the right, I must do to the left. So now 3x minus 2x is x. I get x minus 6 equal 10. To get x by itself, I'm going to add 6 to both sides. So I get x equals 16, and I'm done. There's your answer. So x is 16. All right, so that's that one. Now let's look at this one. Okay, now number 3, you have this. You have 1 divided by x plus 3 plus 7 equals 10 divided by x plus 3. All right, now notice you have this rational equation because notice the denominator, at least one of the denominators contains a variable. So you got to find the least common denominator. So remember, your least common denominator is going to include every factor you see in the denominator. So I see an x plus 3. So I need an x plus 3. So remember, you want your least common denominator to be something that this denominator reduces into. So if you see an x plus 3, you need an x plus 3. The next one I see is x plus 3. Well, that's the same as this one. So I already have it. So your least common denominator is just x plus 3. That's your least common denominator. Now, just like we did in number 2, we're going to multiply both sides by the least common denominator. But notice I put this side in parentheses because you have two fractions, this one and this one. Over here, I did not put in parentheses because it's just one fraction. It wasn't needed. So over here, you have two fractions. So put that in parentheses. 1 divided by x plus 3 plus 7. And we'll multiply both sides by the least common denominator, x plus 3, equal 10 divided by x plus 3 times x plus 3. All right, and now you use your distributive property. So I get x plus 3 times 1 divided by x plus 3 plus 7. Now be careful. So this 7 is multiplied by all of this. So you got to put all of that in parentheses, just like this. 7 times x plus 3 in parentheses equal, and I'm going to just rewrite this over, 10 divided by x plus 3 times x plus 3. Now remember, just like we did this, once you get to that point, the whole purpose of multiplying by the least common denominator is to get rid of those fractions. So you want the number 1 in its place. So if I want this to be a 1, then this better be here. If I want this to be a 1, then this better be here. And so now look at what you have. Now be careful as you go through this. Go from left to right. 1 times 1 is 1. Plus, and I'm going to rewrite this over, 7 times x plus 3 equal 10 times 1 is 10. All right? Now here's where some students mess up. They want to say 1 plus 7 is 8, and then distribute the 8. Well, remember the order of operations. The order of operations says you have to multiply before you add. So question becomes, do I say 7 plus 1, or do I distribute the 7 first? Distribute the 7 first. Very good. So this becomes 1 plus 7 times
Distribute
x
the
is
7
7x.
first.
7 times a positive 3 is a positive 21 equal 10. And then combining like terms, 1 plus 21 is 22. So I get 7x plus 22 equals 10. And then subtracting 22 from both sides. And then combining like terms, I get 7x equal 10. Subtract 22 is a negative 11. And then to get x by itself, I divide both sides by 7. And then the 7's divide out. So you get x to be negative 11 sevenths. Or as a mixed number, it will be negative 1 and 4 sevenths. All right, now, one thing I need to go back to is this. So whenever you have a rational equation, you're going to have to find the restrictions. So I want to go back. Hopefully it's still up here. So let's see if I can get back to it. I want to go back and see. I don't think it's in that one. And we also need to talk about this. So notice the direction says solve the equation, then determine whether the equation is identity, a conditional equation, or an inconsistent equation. Let me go to, hold on just one moment. Okay, so when I go back to the agenda, and I go back to week 1, let me show you week 1. So here's week 1. Scroll down, and let's see. There was one, I wonder where it is. Oh, here it is. So right here, see where it says classifying equations? That's what you're going to need for that question. So classifying equations. So when you go here, when you go here to this right here, this is where we start talking about identity, conditional equation, inconsistent. All right, so classifying equations was in week 1. So when you do this, you're going to need week 1 information. Okay, now, let me go back and say what this means now. So in terms of identity, conditional, and consistent. So let's remind ourselves what those are. All right, so let me go back to this. Okay, so a conditional equation is an equation in which there is a finite number of solutions. So that's one way to think about it. So finite means you can count. So when I go here and I look at that, the number of solutions, how many solutions do you see here? How many solutions does this equation have? No, one. Solution have one solution, so a finite number. So if that's a finite, then this is a conditional
So,
equation.
wait, one?
Okay. Let me see if I can find one where there's no solution. Let's see. I have to probably make one up. Well, let's go ahead and make one up. All right, so suppose, so when you do this one right here, this right here, so if you get a solution, let me actually, so I'm going to write this down. I'm going to write it down. You have 2x divided by x minus 2 equals 4 divided by x minus 2 plus 5. All right, so when I come back and I do this one, what's the LCD here? Come on, real quick, x minus 2. So you can multiply both sides by x minus 2. So you have 2x
X
divided by x
minus
minus
2.
2 times x minus 2 equal, and then on this side, you're going to put that in parentheses because you have two fractions. And you multiply by x minus 2. Okay, now I'm going to go ahead and distribute here. I'm going to just rewrite this one over. X minus 2 times 2x divided by x minus 2 equal, and then x minus 2 times this, times 4 divided by x minus 2, plus, and then 5 divided by x minus 2. All right, now, remember, once you multiply both sides by the least common denominator, then those denominators should be factors of 1s. So the x minus 2's divide out, these x minus 2's divide out. And so you get 1 times 2x is 2x equal 1 times 4 is 4 plus, and then 5 times x minus 2. Now, just like we mentioned a while ago, some students are going to make a mistake. They'll say 4 plus 5 is 9 and then distribute the 9. Remember, you got to do multiplication before you do addition. So you have to distribute first. So 2x equal 4 plus 5x and then minus 10. Combining like terms, 4 and a negative 10 is a negative 6. I get 2x equal 5x minus 6. All right, what I'm going to do now is I'm going to subtract 5x from both sides, just like that. And 2x minus 5x is a negative 3x equal, this is 0, and you get negative 6 left. To get x by itself, you're going to divide both sides by negative 3. Because right now I'm multiplying by negative 3. Negative 3 divided by negative 3 is 1. 1 times x is x equal negative 6 divided by negative 3 is a positive 2. Okay, now we have to be careful. So right here, when we go back to the original problem, you had a denominator with a variable in it. So you have to think about restrictions. You have to think about those restrictions. So the restrictions are these. The restrictions are what numbers can't I use in my variables? So whenever it's a rational equation, to find the restrictions, you just look at the denominator. Remember, you can never divide by 0. So if you said, for example, if you said 8 divided by 0, you get an error. It's undefined. So to find the restrictions of a rational equation, you just look at the denominator. What value of x will make x minus 2 0? You can even guess at that. What number minus 2 is 0? Anyone? 2. 2 minus 2 is 0. So my restriction is that x cannot equal 2. And that's the same thing here. 2 minus 2 is
2.
0. So there's only one restriction. The restriction is x cannot equal 2. But notice, when I solve this equation, what did I end up with? 2. But that is a restriction. So I cannot, so that means this. That means that x equal 2 is
2.
not a solution. That's what that means. X equal 2 is not a solution. So when you go over here and we look at this right here, and you ask for the solution, so what is the solution set? Is the solution set a single number? Is it 2? Because that's what we got, right? Is it all real numbers, or is it the empty set? What do y'all think? Is the empty set. It has no solution, so the solution is the empty set. So you'd say solution
Empty set.
and just put empty set. Okay? Or and what some people will do is they'll say no solution, and that's fine. But in my lab, they're not asking for you to say no solution. They want you to actually say the empty set, which implies no solution. So you're going to do C like this. You're going to check your answer, and then you're well done. But then it asks you this now. Determine whether the equation is identity, a conditional equation, or an inconsistent equation. All right, so remember, a conditional equation is an equation that has a finite number of solutions. Did this have a solution? No. What's the solution? No. Be careful. So let's go back and talk about this. X equal 2 is a solution to this linear equation. But my original problem was not linear. My original problem was what kind of equation? A rational equation. So then, since it was a rational equation that had variables in the denominator, you had to find the restriction.
Irrational?
So the restriction in this case was 2, because 2 minus 2 is 0. It's whatever makes my denominator 0. So x equal 2 is not a solution to the original equation. It's a solution to the linear equation you see here, but not the rational. So x equal 2 is not a solution. The solution to the original equation is no solution. There is none. It's the empty set. So remember, a conditional equation is an equation where you have a finite number of solutions. You can count them. Does this equation have a solution? No. Okay? An identity is where you have an
No.
infinite number of solutions. Well, remember, this one had none to begin with, so it cannot be an identity. So which choice is left? Inconsistent. So if I do that, hopefully it'll be correct. Yeah. All right. So you get that.
Inconsistent
All right, so that's how
equation.
you do that. Okay? And so the same thing here, identity, conditional, inconsistent. Notice, I'm going to ask this, just see, all of you agree that this is linear, because you have x to the first, x to the first. Is this also considered rational, yes or no? Can I consider this a rational equation? Yeah, because you have fractions. Even though there's no variable in the denominator, it's still considered a rational equation. Do I have to find any restrictions for this one? No, why not?
No.
Yep, very good. There's no variable in the
Because
denominator. All right, good.
there's no
Okay,
variable in the
all right. And
denominator.
let's see. Let's try and do one more possibly. Let's look at this one. So, um, so this will, let's call this number 3. So number 3, let's say we had 4 divided by 3x plus 3 equals 6 divided by x plus 1 minus 4/3. Okay, what kind of equation is this? This is actually number 4, I think. What kind of equation is this? It's rational. Okay, so I got to find the least common denominator. All right, now one other thing you got to remember is before you find the least common denominator, you have to make sure that all of these denominators are factored. So if you notice 3x plus 3, you can factor out a 3. So this becomes 3 times x plus 1. That's what that is. And now you can find the least common denominator. So I see a 3 here, and I see a 3 here. So do I need a 3 in the LCD? Yes. I see an x plus 1. I see an x plus 1. What do I need?
Yes.
So my LCD is going to be 3 times x plus 1. And always verify, will
X plus 1.
this go into this? Yes.
Correct.
Will this go into this? Yes, because I see it. Will this go into this? Yes, because I see it. So that's your least common denominator. So the first thing you had to recognize was you had to factor this particular denominator. All right, I'm going to go ahead and rewrite this over so I can multiply by the LCD. So, let's find the restrictions. Forgot to do that. All right, restrictions. What can't x be? And all you do is look at the denominator. So you see this x plus 1? What value of x will make x plus 1 0? What do you think? What number plus 1 is 0? No, 1 plus 1 is 2. It's okay. What is it?
1.
Negative 1. I think that's what y'all said, right?
Oh, I'm
Zero.
sorry.
Negative 1 plus 1 is what? 0.
Zero.
And really all you do is this. Watch. All you do to, without having to guess, is this. You say, where is x plus 1 equal to 0? And you solve for x. So subtract 1 from both sides. You get x to be what? Negative 1. So that's all you're doing. And then this I already did. Negative 1. Is this ever 0? No, because there's no variable. So there's only one restriction, and that restriction is negative 1. Okay, so now what I'm going to do is I'm
No.
going to multiply both sides by the least common denominator. So I'm going to say this, and using the factored part, times the LCD. So 3 times x plus 1 times 4 divided by 3 times x plus 1. So this is this. Equal, and then the LCD times this side. 3 times x plus 1 times 6 over x plus 1 minus 4/3. All right, so now I'm going to go ahead and distribute on this side. And right now, I'm going to go ahead and do this. I'm going to go ahead and reduce these part here. So those divide out. So 1 times 4 is 4. Equal. And so this LCD times the first fraction minus, and then the LCD times the second fraction. Okay, now reducing just like I did here. Remember, the whole purpose of multiplying by the LCD is to get rid of those denominators. The x plus 1's divide out, just like that. And these 3's divide out. And so I have 4 equal 3 times 1 times 6 is 18. Subtract 1 times x plus 1 times 4 is 4 times x plus 1. So that's what I have. Okay, now do I say 18 minus 4? No, you have to do what first? Distribute. So, but I'm going to go ahead and distribute the negative 4. So I get 4
No.
equals 18. A negative 4
Distribute.
times x is a negative 4x. A negative 4 times 1 is a negative 4. All right, combining like terms, 18 subtract 4 is 14. So I get 4 equals 14 minus 4x. Now I got to get x by itself, so I'm going to go ahead and subtract 4 from both sides. I'm sorry, 14 from both sides. And so I get 4 minus 14 is a negative 10. Equal, this is 0, a negative 4x. One more step when you're done. What do I divide both sides by? Negative 4, yeah, negative 4. And remember, negative divided by negative is a
4.
Negative 4.
4.
positive. And then what's 10/4 reduced? They're both divisible by 2.
Positive.
5 over 2. Equal, and then negative 4 divided by negative 4 is 1. 1 times x is x. All right, now,
Over 2.
so this 5/2 is a solution to this linear equation right here. Is it a solution to the original? Yes or no? Yes. Why? It's not the restriction. So here's your
Yes.
solution. So this is it. So assuming I get all
Because
this one correct,
it's not
this
negative
is a
1.
solution. And then is it if we go back and answer the question about conditional, identity, or inconsistent, is it a conditional equation, identity, or inconsistent? Conditional, because you can count how many solutions there are. How many are there? Just one. It's a conditional equation. Okay. All right. And then
1.
real quickly, one other section you have to learn this week is on complex numbers. Now, don't make complex numbers that difficult, but complex numbers. Now, before we talk about complex numbers, some things in that section talks about simplifying square roots. So let's talk about simplifying square root. What is the square root of 16? 4. So you're looking at perfect squares. So the idea of perfect squares.
4.
So when you
4.
think about square roots and simplifying square roots, you think of perfect squares. So the smallest perfect square, what do you think that number is? What's the smallest perfect square? 2 is not a perfect square. Anyone else?
2.
2.
4 is a perfect square. I agree. 4 is a perfect square because the square root of 4 is what?
Is it 4?
2. So when I square 2, I get 4. So 4 is a perfect square.
2 and 2.
What's another perfect square? Say it again. Okay, so 16 is a perfect square.
So,
That's true.
oh, I was fine about to say 4 and 4
Because 4
is
squared
16.
is 16. 1, yes, because 1 squared is what? 1. So 1 is the smallest perfect square. The next one
Would
is
it be
4.
1?
The next one, see how they see the pattern? 1 squared, 2 squared. What's the next one? 3 squared, which is 9. 4 squared is 16. The next one is 5 squared, which is 25, and so on. All right, so that's how you get those perfect
9.
squares. So these are your perfect squares. There's an infinite number. The next one after 25 is, what is it? 36, because 6 squared is 36. So is 16 listed here?
36.
Yes. So so that means 16 is a perfect square. So that means it's a nice number. What's the square root of 16?
Yes.
Yeah.
No.
What number times itself is 16? 4. Okay. Now, what if I had this? The square root of 32.
4.
Is 32 a perfect square?
4.
No. because there's no number times itself that's going to be 32. But is there a perfect square
No.
that goes into 32? Will 1 go into 32? Yes, in fact, 1 goes into all those numbers, right? Will 4 go into 32?
Yeah.
Yes. So I can simplify the
Right.
square root of 32 using 4, but always make sure you use
Yes.
the
Yes.
largest. Are there any other perfect squares that will go into 32? Yeah, which one? 25 does not go into 32 evenly. 29
Yes.
times the
25.
whole number is 32.
9.
What? So there's one here. There is a
Then
perfect square other than 4 that goes into 32. What is it?
16.
7 is not even listed. 16. 16 times 2 is
7.
what?
or
16.
32. So the way you want to simplify this is the square root of 32 is the square root of 16
2.
times the square root of 2. 16 times 2 is 32. And then I can simplify the square root of 16. What's the square root of 16? So you get 4 square root of 2. So when you're asked to simplify radicals, that's the idea.
4.
You want to look for perfect squares. So if you have the square root of, let's say, 8, can I simplify the square root of 8? Is there a perfect square other than 1 that goes into 8? 4. Square root of 8 is the square root of 4 times the square root of 2. 4 times 2 is 8.
4.
What's the square root of 4? So you get 2 square root of 2. If we have the square root of 27, can I simplify the square root of
2.
27? Yeah, 9 times what? Yeah, 9 times 3 is 27.
It'll
What's the
be
square root of
9.
9?
The square
So you get 3 square root of 3.
3.
Can I simplify the square root of 38?
3 and
3.
3.
Is there a perfect square that goes into 38? So this is which one? 4 times what whole number is 38? I
Yes.
don't think there's any, right? And then 38 is even, so I cannot use an odd number. 16 times what's 38? There is no whole number.
No.
25 is odd. The next one's 36, and then you're almost past 38, so you're done. So can I simplify the square root of 38? No, in fact, remember, the only perfect square that goes in 38 is 1. So you would say can't
No.
be simplified.
Mhm.
All right, now, so then you're going to have something like this. Watch this. The square root of negative 9. So we know that the square root of 9 is what number? 3. What do you think the square root of negative 9 is? Okay. So remember, the square root of
3.
9 is 3. That means 3 times 3 is what?
Negative 3.
9. So if you say the square root of a negative 9 is a negative 3, then you're saying a negative 3 times a
9.
negative 3 is a negative 9. Is that true? It's a positive 9, so that cannot be true. So the square root of a negative 9 is not a
Oh,
negative 3.
no, we still give
In
it a
fact,
positive
if you
9.
look at your calculator, watch. So if I take the square root of 9, I get 3. If I take the square root of a negative 9, I get an error. That means you cannot take the square root of a negative number and get a real number. So this is not a real number. We even saw that. You get an error. But you learn about imaginary numbers. So you may vaguely remember something about that either from this week, because I think it's in this week's lessons, or from a previous course, imaginary numbers. So when you think about imaginary numbers, you think of that letter I. Remember that letter I? Imaginary number? So I is defined to be the square root of a -1. That's what I is defined to be. I is defined to be the square root of a -1. So watch. The square root of a -9, square root of a -9, do y'all agree? I can write this as the square root of a -1 times the square root of 9. Yes or no? Why not? Over here, what's 9 times 3?
No.
Okay. What's a -1 times 9? -9. So I'm going to ask again, do
27.
y'all agree I can write the square root of a -9 as the square root of a -1 times the square root of 9?
-9.
Yes. Now, what is the square root of a -1 the same as?
Yes.
Yes.
I times, what's the square root of 9? 3.
I.
But we prefer not to write as I3, we prefer to write it as 3I. So the square root of a
3.
-9 is 3I. Square root of a -9 is 3I. So whenever you take the square root of a negative number, you're going to get imaginary numbers. All right, it's not a real number, but now you know about imaginary numbers, so you can never use the phrase not a real number. You're going to have to use I's now if you get a square root of a negative number. Okay, now, you remember a while ago we said the square root of 9 is 3? Because 3 times 3 is what? 9. Well, we're saying the square root of a -9 is 3i, right? So let's check it. So that means 3i
9.
times 3i has to be what? -9. Well, what's 3 times 3? 9. What's I times I? I squared.
9.
It's kind of like saying x times x is what?
I.
No, be careful.
Okay.
X plus x is 2x. What's x times x?
2x.
X squared. So I times I is I squared. All right, now watch this. See this right
X
here?
squared.
Well, okay.
Okay, listen carefully. I'm going to go ahead and rewrite this over. Oops, sorry, I did not mean to put that here. Let me redo it. I equals square root of a -1. So if I, this one right here, if I square both sides like that, I get I squared equal, and then the square and the square root undo each other. So what's left do you see here? -1. So I squared is defined to be -1. So I is
-1.
defined to be the square root of -1. I squared is defined to be -1. So when I come here, what's I squared equal to? What's I squared equal? So this becomes 9 times -1. And what's 9 times -1? -9.
-1.
Okay? All right, now let's look at this.
-9.
Okay, so that's number 7. So number 7, let's suppose we have, let's see if I can quickly find it. Okay, so I have the square root of a -20. I want to simplify this. Simplify. First of all, is this a real number? No, because I cannot take the square root of a negative number. But I do now know about imaginary numbers.
No.
So I know that I can rewrite this as square root of a -1 times the square root of 20. And what's the square root of a -1? All right, now I got to think about 20. Is there a perfect square that goes into 20
I.
besides 1? Oh, yes, there is. 4. 4.
No.
4. So I can write 20.
Oh,
I can write the
5
square root of
times
20
4?
and
is the square
two.
root of 5 times the
Right,
square root of 4,
okay.
right? And so what's the square root of 4? 2. So this becomes 2 square root of 5, right? So this becomes I times 2 square root of 5.
Two.
Now here's the thing with this one. So remember a while ago we said that instead of saying I times 3, we prefer 3I. So always put the I in front of that the part that looks like an integer, like a whole number. So right here, instead of saying I times 2 square root of 5, I'm going to write this as 2 times I times the square root of 5, like that. So that means the same thing as this. What some students do, though, and that's okay, is they put I at the end. So they'll write it as 2 square root of 5 times I. Just be careful, though. If you put it at the end, be careful how close you put it to the square root, because some students will do this. They'll say this, and they'll put it so close to where the I is under the square root. Is I under the square root of 5? No, it's on the outside, so be careful how you write it. All right, so that's why when I write
No.
I and there's a square root there, I always put it between that whole part and the irrational part. Okay, number 8. So the idea of complex numbers is this. So let's talk about complex numbers. So we know what an imaginary number is. Now let's talk about a complex number. A complex number is a number that can be written in the form a plus bi. So notice you have the imaginary part. So you have the real part and the imaginary part. So when I have this, I'm going to make a simple one here. So let's simplify. 7 plus 2 plus 3i. Combine like terms. I have 3 terms here. Which 2 terms can I combine? Yeah, so 7 plus 2 is what? Yeah, so you got 9
7
plus
and
3i.
2?
And that's it. Those are not like terms anymore because that has an I in it. This does not.
9.
So that's of the form a plus bi. A plus bi. So when I look at number 9, let's say I have 1 plus 6i plus 3 plus 5i. So I want to add these 2 complex numbers. So all you're doing basically is just combining like terms. 1 plus 3 is what? 4. 6i plus 5i is what?
4.
11i, right? So there's your answer. So 4 plus 11i. Now this one was
Yeah.
easy because of
11.
the addition symbol right here. So look at number 10. Suppose we had a subtraction. Suppose I had 3 minus 7i, subtract, and then 2 minus 9i. What I would do first is I would convert this to an addition problem. Or if you want to, you can go ahead and distribute the negative 1. It does not matter. Basically, you have this. Watch. 3 minus 7i, and then distribute the negative 1. The opposite of a 2 is what? Negative 2. The opposite of a negative 9i is a what? Positive
A
9i. And
negative
then combine like terms. 3 and a negative 2. What's 3 and a
positive
negative 2?
9.
No, not negative 1, but what? Positive 1. Now, what is a negative 7i?
A
Be
negative
careful.
1.
A negative 7i plus
A positive
9i.
1.
What is that? 2i. So you get 1 plus 2i, and there's your answer. Okay, number 11. So
2i.
you know how to add 2 complex numbers. You know how to subtract 2 complex numbers. Now let's talk about multiplication. Well, actually, let's do this one first. Let's go ahead and subtract these. So I have 4i minus 16 minus 2i. All right, you're subtracting. So let's kind of do it like this. So let's get rid of the parentheses. So go ahead and distribute or add the opposite. Either one doesn't matter. So when I get rid of the parentheses, I get 4i, and tell me what the rest is. Minus 16, now be careful here, plus 2i. Now combine like terms,
Minus
what do you get?
16
4i and
plus
2i.
2i.
But be careful, 4i plus 2i is what? 6i.
Two
And then
I.
notice when we put in the form a plus bi, and they're going to ask you to do that.
Oh,
Always
I'm
put the
sorry.
I part last.
6 I.
So when you write this, you're going to say negative 16 plus 6i. So always put the imaginary part second. All right, now let's do a multiplication. So number 12, let's say we had negative 2i times 8i minus 3. All right, so for that one, you see you're multiplying, right? That's a multiplication right here. Negative 2i times. So what comes into your mind if you want to get rid of those parentheses? Yeah, but the distributive property though, correct? So you have this. Now be careful. You have
Distribute.
I'm going to go ahead and write it out. You have negative 2i times 8i.
Right.
Y'all agree that's what this is? And then plus a negative 2i times a negative 3. Y'all agree that what I wrote here is this? Okay, now let's look at this part right here. What is a negative 2 times 8? Be careful. I times I is what? I squared. So this is a negative 16i squared.
Negative 16i.
Yeah, be careful when you get to that point.
I
And then over
squared.
here,
Squared.
plus, what's a negative 2 times a negative 3? Positive 6. So what's a negative 2i times a negative 3 then?
A positive
6i.
9. I mean a positive
See, this
6.
was an I squared because I times I is I squared, but that's just one I
Positive
to the first
6i.
here. Now, let's simplify this. What is I squared the same as? Yeah, so replace I squared with negative 1. So this becomes negative 16 times negative 1
Negative 1.
plus 6i. And what's a negative 16 times a negative 1? Yep, so you get 16 plus 6i. And there's your answer. That's all you do.
Positive 16.
So you have to remember that I squared was negative 1 to simplify this. All right, 13. Let's suppose you had 6 minus 3i times 2 plus 5i. What do you think you're going to use here? You want to multiply these two binomials. What do you think? Okay, FOIL. Yep, FOIL. Now here's the idea of FOIL. So remember FOIL, first, outer,
FOIL.
inner, last. So first means this. You take the first terms of each binomial and you multiply. What's 6 times 2? 12. O means outer. You take the terms on the outside and multiply them because that's multiplication right here. See,
12.
multiplication. 6 times 5i is 30i. Inner means the terms on the inside. A negative 3i times 2
30i.
is a
30i.
negative 6i. And the last means the last terms of each binomial. Now, this is where you have to be careful.
Positive negative
A
6i.
negative 3i times a positive 5i. What's that? Very good. I squared. Negative 15i squared. And
Negative
and
15i
yeah.
squared.
I have a question. You
Well,
only
you got to remember something from a
squared
previous
the I
course.
when
So if I
you're
had
multiplying.
x times x times x. So remember, you multiply like bases, you add exponents. 1 plus 1 plus 1 is what?
Mhm.
3. So x times x times x is x
Mhm.
cubed. If I have x to the 4th times x squared, that's x to what
3.
power? 6. You add
Okay.
exponents. When you multiply like bases, add exponents. 4 plus 2 is 6. So I have I times
8.
I. That's I to what power?
Oh, okay.
I to the 2nd. All right. So it's the same idea of what you learned before. The idea of multiplying like bases, you add
2nd.
exponents. All right. Now let's go ahead and simplify. First of all, we got to remember that I squared is equal to
Okay.
what number? -1. I also know I can combine these two right here. What's 30i and a -6i?
-1.
-1.
30 and a -6. 24. So it'll be 24i, right? So I get 12 plus 24i, and then minus 15 times, and
24i.
what's I squared? -1. Now let's simplify this part right here. What's a -15 times a -1?
-1.
So I get 12 plus 24i plus 15. And now one last step and we're almost done. 12 and 15 is, so I get 27 plus 24i. All right, and then
27.
one more with this and we're almost out of time. So let's say I had 7 plus 2i squared. How would you do that? You have a binomial squared. How would you do that? Fall again, except this time I would remember 4
We FOIL
squared means
again?
4 times 4, right? Y'all agree? Okay, so that exponent tells you how many times to multiply the base by. So here my exponent is 2. So that means I take 7 plus
Yes.
2i and I multiply it by itself. And then you just do it the same way you did this. First outer and last.
Times
So
7.
first, 7 times 7? 49, right? The outer, what's 7 times 2i? 14i.
Yes.
Inner, what's 2i times 7? 14i again. So it turns out that
14i.
whenever you square a binomial, the outer
14.
and the inner are exactly the same. And then the last, now that's where you have to be careful. What's 2i times 2i? First of all, what's 2 times 2? And what's I times I? Okay. Now let's combine these two like terms right here. What's 14i
4.
plus 14i?
I squared.
Not 28i squared. Remember, the only time you get I squared is if this was
28i
I times
squared.
I. Is that a multiplication right here? Well, it's not. Don't get
So
lost.
it's
It's kind of like if I say what's
20.
2x plus
Huh?
2x. What's
go
2x plus
ahead, I'm
2x?
lost.
4x. Yeah. So if I said what's 14i plus
Oh,
14i is
4x.
just
So
what,
it's just
28?
simply AI.
20.
See, you're with multiplication. So if I had 2x times 2x, what's 2x times 2x?
Okay. So with
Be
with
careful, not 4x. It's
subtraction,
4x what?
okay,
4x squared, because you're multiplying
4x.
x times
Okay.
x.
So it's only
So if I have 14i times
Squared.
14i, let's see, 14. Yeah,
Okay.
14 times 14 is 196.
it's
So
That
that's
would
going to
be
be 196i squared. So
squared.
here you're adding, uh-huh.
Oh, shit.
so that would be I squared. So
Yeah,
we
just
only
like
square it.
variables.
I'm sorry, we only
Just like with
square it
variables.
when it's
Well,
multiplication. When it's adding, we just
okay,
simply
so
carry it over.
14i plus
Okay.
14i is 28i. And now remember, this I squared is equal to what number? -1, right? So I get 49 plus 28i. And what's 4 times a -1?
-1. Yes.
All right, now what's 49 minus 4? You got 45 plus
Negative
28
four.
on
Negative
in your
4.
answer. All right. So in let's see if I can
45.
quickly pull it over. So when you um, quickly go, well, when you get it out, but when you get to my lab, you're going to have. I think this is section 1.4. So at 1.4, you're going to have these imaginary numbers and complex numbers to deal with, and that was it. All right. So I ran out of time. Just make sure you are. So I can get back to this. Hold on. Okay. Make sure that. Okay. Make sure you're going to the home page and you're going to the agenda. And I think I think we may have covered. Well, so I'm not going to assign my lab. I'm not going to assign the quadratic equations yet because we're going to finish it next week. But you need to. We haven't talked about quadratic equations tonight because we didn't have time. But the lessons are there. So you have a non-graded worksheet here. You have 2 9 here, 1 here. So there's only one graded worksheet. So use see this right here. Let me point to it. So these 2 non-graded right here and this one here should help you with this one because you see it says square root property. So this was one that deals with square root property. So use this and these two to help you with this. But the lessons are here. Just click on this link, it'll give you those lessons. All right. And we didn't, oh, and also right here, notice the discriminant. It says, now there's no worksheet on it, no graded worksheet, but it says you will need this lesson in my lab for section 1.5. But I'm not going to assign 1.5 until after next week. But I am going to assign, let me go ahead and get to it. I am going to assign section, where is 1.4? I'm going to assign section 1.4 because we're done. We just talked about it. Okay? All right, any questions? All right. Uh-huh. It'll be, well, be careful how you're asking that. So let's see. So I'm looking at section 1.4.
So, section 1.4
Yeah, I don't
is
have
going to
any
be a
graded
graded
worksheets for
assignment.
1.4. What I'm saying though is that on my lab, it'll be graded. It won't be for you to turn in for any work, but it's a grade in my lab, right? 1.4. You don't have a graded worksheet. You the only thing you see is a non-graded worksheet. But sometime later this week, I'm going to
Yeah, you
assign
saying my
1.4 to
lab
my
has
lab.
a 1.4
So
section that we
so
need to complete.
when you look at this part here,
Mm-hmm.
this right here, you're going to see 1.4 in here. Okay. All right. I think I think I may have. So I went over, but I think
Mm-hmm.
I mean we did as much as we can in a hybrid class. So most of your work
Okay, I
was done
understand.
online, outside of class, I should say. Now remember, next week we're meeting on campus, and many times I give an in-class worksheet. But remember, if you're not able to come, that's okay because you can drop the lowest 25% of your worksheets. So just keep that in mind. So if you have an emergency, then that's going to be one that you're going to drop. All right. So try and attend class as much as possible because it is important. And you remember your when is the first test? I'm going. Let's go to the syllabus. The syllabus is right here. Your test and the tests are face to face at the RCC at 6 o'clock. your first test is right here, and that is February 21st. All right, so keep in mind when that first test is. And I'll give you a study guide probably about the week before. Okay? All right, so I think I recorded this, but actually there was some MyLab on here, so I don't know if they're going to, whoever goes to this first will not let me send it
Okay,
to
sir.
y'all because MyLab is in here, but we'll see. Okay, because let me go ahead and do this. Hold on.